Namaskar, my dear friends. Let us talk about FPGA from Lattice Semiconductor. So, Lattice Semiconductor is one of the biggest FPGA manufacturer. Okay, what we can do is we can try to understand how to target Lattice FPGA, which is CrossLink-NX family. Okay, so we are going to talk about CrossLink-NX family FPGA system schematic design techniques and all other details. So before moving to that, we will be talking about what are the different things that we need to take care of or look into before getting into the system design. So as you can see, if you go to Lattice Semiconductor web page, you will have a various like categories of FPGAs that Lattice Semiconductor has in their portfolio. Like we have control and security FPGA, that is Max series. Okay, then we have general purpose FPGA like Avant X, Avant G and all these, Certius N2, Certius Pro. Then we have ultra low power FPGAs, which is IC40, Ultra Plus, Ultra Light and everything. And then we have video connection FPGA. Okay, so we'll be talking about each of the categories one by one in our upcoming videos. However, our target is going to be this series. Okay, video connection FPGA. So in that video series connection, we will be targeting CrossLink NX. Okay, this is my target family. Understood? Now let us get into the understanding of this. CrossLink NX has two series, one is 17 and one is 40. So if we talk about from the data sheet, if you see, we have the device selection guideline. In that we have LIFCL 17 and LIFCL 40. So LIFCL 40 is having higher version or like higher capabilities compared to LIFCL 17. You have the number of logic cells. Then LIFCL 17 is preferred because of its very low cost, low pin count and everything. That's the reason I have several designs using LIFCL as well, 17 as well as we'll talk about LIFCL 40 devices as well. Now if you see, we have embedded memory which is going to be 24 into 18 kilobits. Then we have embedded memory ER bits, that is 432. Then we have distributed RAM bits, large memory blocks are there. Then we have large memory LRAM bits is there. We have multipliers, that is 24 multipliers are there. We have ADC blocks, we have frequency oscillator, we have low power oscillator. Okay, then we have gigabits PLL, and then we have hardened 10 Gbps DPHY. Okay, that is physical layer. So similar to that, all other parts are there. If you talk about packages that is available with this device, so you have these many packages like 72 pin WLCSP package is there, and then QFN package is there. Okay, so we have designed several from QFN package of 72 pin. Then we have 128, 121, this 121 CS FPGA package, then 256 CA BGA package, 289 CS BGA package, and 400 CS BGA package. Okay, so we'll be giving you design with 400 CS BGA package as well as 72 pin QFN package. So these two designs will give you with various applications. So why don't we do one thing? Before that, I just want to make sure one thing about like designing the power supply for this particular FPGA CrossLink-NX series. Okay, so you can see there is no power up sequencing required for CrossLink-NX devices. So let us say you have a requirement of 1 volt and 1.8 volt, and let us say 3.3 volt of your VCC or something, or 2.5 volt VCC, and let us say 1.35 volt for your DDRs and all. So all these voltage like rails, there will not be a requirement of any voltage power up sequence. Okay, like which voltage should come up first or last, that is not a problem at all. Okay. Now let me give you the design document that we are going to discuss. So you can see we have the Lattice Semiconductor FPGA family dataset, which is the CrossLink-NX family. And this I'm not going to go ahead because I will be giving you the design document that we have done. Okay, So let us get into our design document and we'll tell you what is the thing. Okay. All right. So we are now going to move to FPGA system design. So in this FPGA system design, what we'll be doing is we'll be talking about CrossLink-NX FPGA family. Okay. So let us come down. Okay. So if you, I will put the product link as well, so you can directly get into, like Lattice Semiconductor CrossLink-NX family from this link. So this I will put it in the description box. Coming back to the device selection guidelines. So device selection guideline, just now I told you like LIFCL 17 and LIFCL 40 we are talking about, and their logic cell and embedded memory and all these comparisons we just now talked about. Okay. So here you don't have to go ahead again. Now coming back to the, we have packages. So 72 pin package, 72 pin QFN, 84 pin WLCSP, and all other pin packages are available. So this is complete package details. Okay. That I have taken it from Lattice Semiconductor website itself. And you can see you have like wide range, high performance, ADCs and D5 and PCI lane. All these are available in each of the package that is there. Got it? Coming back to the down, you have these are the notes that is there, like you have C for commercial, I for industrial, and A for automotive. And what is the package that is available in which temperature grade and everything, that is also there. Next, we have already talked about package availability, so you can make a note of this. We will be discussing about 72 pin QFN and 400 CSBGA, and later on, based on your requirement, we can go ahead and give it to you 256 CABGA also for a particular requirement, or if you are designing with these devices. All right. And these devices are preferred for your video connection FPGA. Okay. So this video connection FPGA, why it is used is like all video, like camera application, doorbell application, and all those things. This will be one of the most important or most useful FPGA that I have come across. Now, before developing the FPGA application, we must look into the evaluation board so that you can have a good idea like how to proceed with the particular like FPGA system design. So this is the evaluation board link that I have, and I will be sharing you this as well. Okay. So you can directly get into this particular evaluation board link, or you can directly search by yourself as well from the Lattice Semiconductor. So in this workshop, what we will do is we'll try to understand the CrossLink-NX FPGA family design and detail and their pin configuration and everything. Okay. So as you can see, this particular evaluation board, we have, this is the part number that is mounted on the board, and this is the family from CrossLink-NX, and we have 400 balls CA-BGA package. Okay. More detail about the board if you want, you can have like a CrossLink Semiconductor NX evaluation board that makes you, or allows you investigate and experiment various features for this particular FPGA. All right. Let's get into the features of this. So features of this particular device, if you see, you have CrossLink-NX family, then you have general purpose input output breakout for Raspberry Pi. Okay, Raspberry Pi, PMOD are there, then FMC is there. Okay, FPGA mezzanine connectors are there. Okay, and then you have mobile industry processor interfaces like MIPI. Okay, and then we have CSI, that is camera serial interfaces, and we have camera connection and D5 connectors. Coming back to the more, you have 118 wide range and 37 high speed differential pairs IOs. Okay, and you have a peripheral component interconnect express as well, that is PCI interface as well. So there are like X1 generation 2 sorry matlab 1 generation 2 PCI interface is there. Now why don't we see the board image? So this is the board image that is there from the evaluation board. Okay. And this is the FPGA. We have PMOD connectors here, and this one we have FPGA mezzanine connectors. Okay. Then you have prototype areas and everything. This is the jet jack input, that is power supply input, and here is the power supply solution. Okay, and this is the soft, deep switches and everything. We have DeFi connector here, physical connector here. So we'll see each and everything one by one. Coming down, this is the back side of the FPGA evaluation board. So you can see back side how nicely it is made. This is the overall view of this particular FPGA evaluation board picture. So evaluation board you can see very nicely. And why I am evaluating, or why I am stressing on this particular evaluation board, is because of the only reason that once you have a proper idea of going through the evaluation board, you will be able to develop your own circuit very easily and very nicely with confidence as well. Okay. So let's get into the FPGA pinout information. So suppose you have to connect some pins of the FPGA, and you want to connect it to some of the things, like, right? Let me give you an understanding. So as you can see, I have the pinout Excel sheet from the FPGA, of LIFCL 17 series, and you have like 121 pin package, 72 pin package, 72 pin package, and 256 pin package. And you can see this is the functionality of each pin, and this is the pin numbers, okay, or pad numbers. So you can see like we have VCCA and everything. Oh, sorry, this is the not pad number. This is the pad number, like E9 or G9 or something like that. So what is the name and what is the functionality, that must be understood. Then only you will be able to design your complete FPGA schematic. So going from here, it is little difficult. Okay. So what we'll do is we'll go to the data sheet and pin functionality we'll see one by one. Alright, so what I have done is I have cut and pasted here. So you have VSS pin, that is your ground pin, VSS D5, that is your D5 block ground pin. Then you have VSSD. So one by one you can see, and what is the voltage level that will be connected, that also is given here very nicely. So if you see VCC 1 volt, similar to that VCC auxiliary, that is 1.8 volt. Similar to that VCC auxiliary, one more is there here, that is analog. This was, and it was digital. So you can see you have bank 0, bank 1, bank 2, bank 6, and bank 7. Then you have VCC auxiliary H, okay, that is also there. Then VCC IO, what are the IO voltage that it can be capable of driving is, you have the capability of 1.2 volt, 1.5 volt, 1.8 volt, through 2.5 and 3.3. So what we have used always is almost 3.3 volt most of the application. Some of the applications we have used 1.8 volt as well. Okay. Coming back to the other parts. So as you can see, this all parts were like pins were for power supplies. Okay. So power supply, other parts are also there, like VCC D5, D5X, D5Y, all are there. Then VCC ADC pin. So ADC pin 1.8 volt ADC block will be required. Then SARDES block will be required 1 volt. Okay. Another PLL and auxiliary power supply is needed. So this was all about power supply for this particular FPGA series. Coming back to the next part, this is my dedicated pin. So JTAG enable pin is there. If you put it 0, then it will act as GPIO, and if you keep it 1, then it will be acting as a JTAG enabled pin. Okay, because JTAG pin is shared with GPIO as well. So if you want, you can have JTAG enabled always, so that it does not give you, like a mixing of JTAG as well as GPIO. Okay. We have ADC. So ADC reference is there, and ADC dedicated pins are there here, like positive and negative, that is differential inputs. Then we have signal, like name, as you can see, you have high speed design. So you can see we have high speed data differential input pairs and data differential output pairs. So SD0 RX is there, that is receiver, and SDDO TXDP. Okay. Then we have reference clock, we have external reference resistors input, and we have reference reset. Okay. Oh, sorry, reference return input. All right. So these are the high speed signal lines. Then we have dedicated D5 pin. As you can see, we have D5, hardened D5 data input output pairs. Then we have data D5 clock input output pairs. So once you are familiar of these pins and their functionality, it becomes easier for you to decide which pin for what purpose we can assign, right? Then we have NC, that is no connect pin, and we have reserved pin, some of them, that is there. Coming back to the general purpose IO pin. So general purpose IO pin, how it is mentioned is, you can see we have P, T, B, L, R. T means top, bottom, left, right. Okay. So top, bottom, left, right, how it is decided? This is your top, this is your bottom, this is your left, and this is your right. Understood? So this is my FPGA, left side, right side, top side, bottom side. These are the pins that is available. Okay. Now you can see we have banks that is available. So top side bank 0 is available, bank 1 and 2 is available, 3, 4, 5 and 6, 7 is available. Okay, and it is like this. So as you can see, you have indicate package ball pin in top side, bottom side, left side, right side, everything it is written. Just now I told you, not a problem. Now coming back to the next part, let us talk about each and every, this was the pin configuration, general purpose IO, what it is, how it is. Now we are going to talk about each one of them. So PR means right side, means right side. So PR means right side, XXX is the number of the IO. Another functionality of this GPIO is SDA and user SDA. So SDA means you can use it for your I2C application as well. So you can see here configurations are like I2C, I3C mode for SDA signal, user mode like GPIO, and SDA signal for I2C, I3C interface. Similar to that, other parts will also be there. This is your clock signal and everything. Other things you can see, you have like TDO, TDI, TMS, and they are shared with your GPIO as well. So if you want, you can JTAG disable it so that TDIO, TDI, TDO, TMS is not dedicated. They can be used as GPIO. Coming to the next part, we have TCK line also, and then MCSNO, MD0, MD2, MD0, MD2. All these things are your your SPI quad mode. Okay, so MD0, then MD2, then MD1, MD0 will also be there. So MD0, MD1, MD2, MD3. So these are the master serial output is there. Now coming back to the other parts, similar to that, other pins are also there. So I'm not going to spend much time here. We have init N, that is your configuration for your, if there is a initialization, how to initialize this. This will be giving you the indication. Now let us talk about it. So init pin, initialization pin is done. Then we have done pin. So once configuration is done, like FPGA configuration is done, then this done pin will be high. So you can see open drain IO pin. This signal is driven low during the configuration, but it is released to indicate the device has completed configuration. Understood? So this is a open drain pin. Similar to that, this initialization pin was also open drain pin, and this signal is driven low when configuration sequence is started to indicate the device is in initialization state. So once it goes high, what will happen? Configuration download is completed. Okay. Now coming back to the other parts, you have other GPIOs like PR, XXX, and all these things are there. You have more TDI, TDO pins are here, like it is actually JTAG pins. So JTAG shared pins are there. So some other JTAG pins can also be there. Then we have clock pins. So you have a PCLK or PCLK T0 and T12. So these things are there. Then you have PLL clock, PCLK clock. Then we have this is actually left side GPIO. This is bottom side GPIO. This is left side GPIO. Coming back to the V reference pin. So for ADCs and all other parts, we need V reference pin. So here we have DDR V reference pin. So V reference 345, that is used for reference voltage for DDR memory functions. You have ADC. So ADC channel input is there. ADC C, P and N. P is positive, N is negative. And that is there in 3, 4 and 5th block. Similar to that, we have differential comparator input comp. Okay, so you can see differential comparator inputs. Then we have like Ethernet connection, that is SGMII. Okay, differential SGRX inputs and all these things are there. Coming back to differential, coming back to other parts. So I think this is all about like pin configuration and pin details. So what we'll do is we'll stop up to this, and in next session we'll go ahead and see about other parts like like we have ADC and programming features and function and how to program this particular Lattice Semiconductor FPGAs. So if you do have any questions or any understanding that is needed for starting your design, or like if you are designing some application and you need some support or require assistant, you can always put down your queries in the comment box and we shall be able to answer you out. Thank you.